Hi, I'm Michael and Reza. This is Harlan Ferguson, and this is assignment 2 for open source. Got my information at the top here. And so the way that I approached this project was, instead of doing a Jupyter notebook or with Colab, I decided to do it as just Python files and then just local files on the computer. That way it kind of just works on any machine. I was under the impression that a few other students did it this way, so that it was okay for me to go with this process as well. The way that I split it up was I just have a file, main.py, which just calls a main menu function, and then I have a secondary file that just has all my functions in it. So now I'm just going to go through all that and then run the program to confirm that it works. So for this project, I had 3 different libraries. I imported random time and math. And I'll explain why later on. So to start, we have the random equation portion of the assignment. So I define a variable, and then I make a symbols tuple that have the 3 symbols that we need. And then just declare 2 separate variables and randomize a number between 1 and 10. And then I get a random operator by using random.choice on the symbols to figure out what symbol is randomly selected. And then I print the current equation, and then what I do is with whatever tuple, with whatever symbol we get from the symbols, we go through an if-else statement, and then depending on what we randomly got, it then does the actual math equation. Because I have it stored as strings, I check for strings, and then once we confirm that it's a match, then we do the actual math. And no matter what, we're returning just the answer. And then I just added this else just in case for some reason something broke. In all of my testing, I never got it to break, but I just figured to have that in there just in case. So this function just returns the answer and also prints it out. Then I have 2 functions for just making sure that the file is okay. So part of the assignment is to open and read the file, and if there's nothing in there, to welcome the user to the game, and if not, just continue on as if they've used it before. So for that, I do a with open, which is what's typically recommended, because then once all this content or once all this code is used up, then it just automatically closes the file, so the file handling is a lot easier. And then for this, I did some research and looked into reading as a binary. That way I can read, I set 4 bytes in this instance because it gives us a large number, I think 1 billion. But we can read for a certain amount of bytes in the file. And then if we do find bytes in the file, this function just returns false. And if we do not find anything in the file, it returns true. For our is empty there. And then part of the assignment was also to check a few different other exceptions that could go on with this. So with is file okay function that I made, we try just reading the file. Super basic. We're not actually doing anything with it. We're just reading it. But the reason I have this is in case we can't read it, then I have a couple excepts here. So we have a file not found error, we have an OS error, and then just like a catch-all just in case some other error appears, which are not those 2. So that just meets the project requirements there. And then just 2 functions to do with score. So we have a getScore function, which just opens and reads. Oh dear. GetScore function just opens and reads. And then returns that content, so we'll get the score once we've already set one. And then this one sets a score, so we pass the function a score, it opens up the file, and then writes a score. You have to convert the score to a string in order for it to write properly, so I do that there. And then we're getting into the bulk of it now. So we have this math1 function. So as per the project requirements, we have a local variable to count the score. We set it to 0, and first we check if the file is okay. So then we go back up to here. So it just tries all these things, And then once the file is okay and that checks, then we check to see if it's empty. So again, with that binary read. And then if it's true that it is empty, it prints welcome to your math game. If it's false, and then we set the score using the get score function. So say we have a score of 5 in this file. 5 would be stored into score, and we print that out for the user. And then we make an infinite while loop here. So first we get an answer using the random equation function, and remembering that in that function that also prints out what the equation is for the user. And then we take the user input, we convert the user input to a string, and then if they equal each other, we say that they did a good job, and then we add 1 to their local score. And then we ask them if they'd like to keep playing or not. If they say they do not want to keep playing, that they'd like to stop, then we use the current score and set it into the new score function, which we'll just write to the file, and then we thank them for playing. And then I added a time.sleep here, just because this kind of got printed really quickly, and then the break hits, and you couldn't actually really read that well. So I just slept it for a second, and then it breaks. And then as per the project requirements, if any other thing is inputted, I have n here for no, but literally anything else, we just go to a continue, and then it just restarts and gives us a new random equation. And then if you get the wrong answer, it lets you know. It deducts -1 from your current score, and then it's just copy paste of above. Once you're done playing, it sets that score to the file. Currently I don't have the file there because I just want to show that it does make one. For the quadratic portion, this is when we get a little bit more mathy. So I make a discriminant function here, just using the discriminant formula. And then we have a quadratic function, which first calls the discriminant functions. We have that stored. And then from my understanding of the math materials given, we have these different equations depending on what the discriminant turns out to be. So if it's a positive number, or if the discriminant is greater than 0, that means that we're going to have 2 answers returned. So I have these 2 equations for that, the plus minus. And then I'm returning a tuple where the 0 index is the amount of answers, and then following it is the answer 1, answer 2. And then similarly, if the discriminant equals 0, we do this specific equation, and then with the tuple we return that there's 1 answer, and then we give the answer. And then else, if it's not a positive number, if it's not 0, that means it's negative, so else. And then that becomes complex, so we return 0 answers, and then we'll have a method for saying it's too complex. So those are the 2 main functions. And then similar to math 1, we have a math 2 function. So say welcome to the game, we collect ABC, we print their equation, and then just with f strings put it just directly in, and then we get an answer by calling the quadratic function. And then I figured out a way to just kind of do this all at once. So we open a file, the quad equation.txt with write. If it doesn't exist, it'll just make one. So again, we don't have those files there yet, but they will be there later on. And then we just write at the very top what their function is, and then do a new line. And then on the next line, it then checks the tuples, the answers, which are tuples. So the first index is the amount of answers. So if index 0 equals 2, we know that those are the real answers, and then we just pull index 1, index 2. And then we print that to the console, and then also write it to the file. And then same with if the answer is 0, so then we just get 1 real answer, we print it, write to file, and then else if they're negative, we say it's negative, too complex, yada yada. And then finally, since I did it this approach and not doing it in a Jupyter, I kind of needed an overarching menu to play the 2 games in one program, because I didn't want to submit multiple files. So now we just have a main program. It just looks for 1, 2, or 3. 1 giving the first game, 2 giving the second, and 3 to exit. And then if we check for if the user puts in 1, we launch math 1. If they put in 2, we launch math 2. If they put in 3, we close the program. And if they put in anything else, we tell them to please put 1, 2, or 3. And then we just call this main menu function here in the main. Easy peasy, nice and clean, 3 lines of code. So now I'm going to run it just to show that it works here. So I'm going to type in, so 1, 2, or 3, I'm going to type in a 6. It's going to tell us to put 1, 2, or 3. So again, I put in that time.sleep just so we can actually read it. So I'm going to put in 1 here to start up the first game. It's going to ask us what 10 plus 4 is. And you can see here, in doing so, it has already made us the new file, but there's nothing in it. So 10 plus 4, we'll put in 14. So it's good work. So now there should be a 1 inside of here. That's a lie. Sorry, it writes it when you're done playing. So let's say we're done playing. So our score is now 1. Now there will be a 1 inside of our score.txt. Now if we run that game again, it says it's happy to see us again, and our last score is 1. So now let's do a couple more things here. So we'll do 15. Would you like to keep playing? 7. And let's get a wrong answer here. So instead of 90, let's put a big answer there. So now it says, sorry, that's wrong. Here's the correct answer. Would you like to stop playing? Yes. So I got 2 right and 1 wrong. So I should have 1 in here, which I still do. And now we'll go on to the quadratic game. So please input a value for A, B, and C. So we'll do 2, 5, and 6. So 2, 5, and 6 were too complex. But we can see up here we made a new file, and we have all that in the new file as well. Forgetting what the test case was for this to make it not complex. It's all complex. 4, 6, 8. Is everything I put in going to be negative? Ay caramba. Here, just bear with me one moment here. So 1, 5, and 6 is what we used for the example. So let's put in 1, 5, and 6. There we go. So we got -2, -3, just like in the example. And as you can see, our file has been updated correctly to -2 and -3 there. So then finally, we can press 3 to exit the program, and it exits successfully. So that is my assignment. Thanks for watching, and take care.